As more sensors are connected to the resources we use every day, we're more interconnected and aware of the state of our systems. Here we're looking at real-time transit feeds in the city of Auckland. There's a little over 900 city buses in Auckland, shown in green, and another 400 service vehicles, shown in orange, operated by the contractor Downer. And we're using the real-time capabilities in ArcGIS to monitor these 1,300 vehicles with position reports and updates every second. GIS is more than just moving assets. It's about bringing together all the related feeds of your sensor networks. For transit, this includes road construction and accidents, intelligent highway signs, and traffic cameras. It's about 6:30 a.m. in Auckland right now, and since we're just at the beginning of rush hour, we're playing back a recorded data set of rush hour at about 10 times the normal rate. Now, as Ian from the city of Auckland mentioned earlier, a common problem during rush hour is congestion and bus delays. And the city also provides real-time updates for the arrival times of each bus at each stop. And here, bus stops with delays are shown in red. By integrating all these different streams of data, a city can be more aware and monitor the health of their systems continuously. As we take a closer look in downtown Auckland, we see additional layers come alive like traffic lights. Buses in the eastbound direction on Cook Street are becoming congested at this intersection, and this is pushing back the arrival times at their next bus stops. There could be an opportunity here to optimize the city's transit. Should they adjust the timing of the lights, perhaps alternate the routes to avoid this particular intersection? With the real-time capabilities of ArcGIS, you're able to fuse disparate data feeds to identify and investigate issues as they occur. Building smarter cities means geospatial awareness not just in real time, but also over time. In version 10.4, we introduced the spatiotemporal data store, which gives you the ability to store and visualize high volumes of observations. What we're looking at here is city bus positions collected over time, and these are the patterns of the service vehicles. Maps from the spatiotemporal data store aggregate your data on the fly, and these dynamic summaries update with the scale of your map. We're visualizing millions and millions of observations, and the aggregate map updates dynamically as new events are received. Real-time data, backed with its historical context, empowers you to make more informed decisions about your networks. But going forward, the number of sensors and the frequency of their data is increasing dramatically. This includes environmental sensors, energy meters, public safety feeds. Even citizens can opt in as sensors themselves using just their phone. Next, Adam's going to lead us through how we can continue to keep up with these massive data flows and use them for insight.
Here we're looking at a sample feed that represents patrons who are sharing their commuting locations through an app on their phone. The distribution of these bus riders, as they move through the transit system, would be extremely valuable for a city to gain intelligence about the quality of their services. But this kind of data can come in at hundreds of thousands of events per second. Handling data at this scale requires a new approach that distributes that feed across a number of computing resources. Next, we'd like to show you a sneak peek of technology that we've been working on along with cloud providers to meet these kinds of requirements. We are bundling a web GIS with the capabilities of GeoEvent, GeoAnalytics, and the Spatial Temporal Big Data Store. But at massive scale, and without you having to sweat the complexities of all the hardware and the software involved. This will be made available later this year as a managed service on the cloud. For the UC, we teamed up with Microsoft Azure to deploy this example across 53 nodes. On this cluster, we are taking in, analyzing, storing, and visualizing hundreds of thousands of events per second. With this distributed architecture, real-time GIS can be scaled as large as needed simply by adding capacity. So questions of any size can be asked.
For example, with historical bus patron data, a city could begin to analyze where and when congestion happens in the ridership of the system itself. Where, for example, are there bus stops with consistently larger numbers of people waiting, especially when the buses arriving are full? Could the city perhaps implement practices to alert these riders of alternative transit? Or where are there bus stops that are underutilized and they could improve efficiency? Public transit, congestion, These are some of the fundamental traffic challenges every city faces. The real-time capabilities of ArcGIS enable you to integrate these valuable real-time and historic data sets that are being rapidly created and bring geospatial understanding to the Internet of Your Things. Thank you.